All right, so now we're going to be talking about the mean value theorem for integrals. Now, in the previous section, we were talking about the definite integral and Riemann sums. We were talking about finding areas using rectangles of things that look like this. Let's say you have some function, so this is f of x, and you want to find the area of this. Well, if you recall, we were using rectangles, say a rectangle that looks like this, to find the area. And if you recall, let's say you had something like this. One of these rectangles gave us an area that was an underestimate. So this red one is going to be an underestimate of the area because it is missing these pieces over here. And the other one will have been an overestimate of the area because it has these pieces over here. So what the mean value theorem for integrals will tell us is that somewhere between the smaller rectangle called the inscribed rectangle and the outer rectangle, which is called the circumscribed rectangle, there's one rectangle between them whose area is precisely equal to the area under this curve on the interval. So there is a rectangle that is perfect in the sense of getting us the area that we want. So let me write down the theorem. We're not going to really use this, but it's useful that you know it. It says the following. So let me put a title since it has one. It's a mean value theorem for integrals. You should go back and review the mean value theorem for derivatives. That's a very important theorem that we had for taking derivatives. So it says the following: if f is continuous on the closed interval AB, then there exists a number C in the closed interval AB such that the following is true. The definite integral from A to B of f of x dx is equal to f of c times b minus a. So this integral, this antiderivative, is equal to the function evaluated at the number c times the difference in the length of b minus a. So one endpoint minus the other. Now, the curious thing to note about this theorem is that this theorem does not tell us how to find that number c. This is something called, this is one of those theorems that's called an existence theorem. It says that there exists a unique number, but it doesn't tell us how to find it. But it does tell us that if you do find it, then it will satisfy this property. So notice this theorem does not tell us how to find C, but it does tell us that it exists. That's instead of it, that C exists. Okay, so we're guaranteed for this to happen. We're guaranteed that on this, again, so you have a function like this, we're guaranteed that on some interval, closed interval AB, there is one rectangle such that the area of this rectangle is precisely equal to the area under the curve. So there is one rectangle whose area is equal to this yellow one. and it's in between an inner rectangle and an outer rectangle, meaning an underestimation and an overestimation. Now, the mean value theorem for integrals leads us to the next theorem, which gives us the average. It's called the average value of a function. This one comes up a lot as well in higher level courses. So the value f of c given in the mean value theorem meaning this one, that one, is called the average value of f. Value of f on the interval AB. Okay. So let me give you the definition of the average value. So if f is an integral function on a closed interval AB, then the average value of f on the interval is the following: is 1 over b minus a times the integral from a to b of f of x dx. Okay, so that's the value of f of c. Remember, f of c is what we're calling the average value. And notice that this is very closely related to the mean value theorem, and let me show you why. First of all, look at what happens when you multiply through by the reciprocal of 1 over b minus a. If we were to solve for the integral, if you multiply both sides by b minus a, actually let me not do it there, let me do it in the bottom. So notice, this is related to mean value theorem. I want to have a break in there. So let's rewrite this. F of c is equal to 1 over b minus a times the integral from a to b of f of x dx. Okay, now if we multiply both sides by b minus a, then the b minus a and b minus a cancel, provided that b minus a is not equal to 0. So long as b minus a is not equal to 0, we could do that. And what we're left with is the integral from a to b of f of x dx time is equal to f of c times b minus a. I'm just going to rewrite the order. But guess what? That's the same thing that we have up here. The integral from a to b of x dx is equal to f of c minus f minus times b minus a. The same thing we have. It's the same thing that we have here. F of c times b minus a is equal to the integral from a to b of f of x dx. So this is the mean value theorem for integrals. So now we have a way of finding that f of c. Okay? Let's do one example using this. You can definitely do more in this, but given that this is not on your final exam, I don't want to divulge too much time into it. But it's good that you see it. So find the average value of f of x equals 3x squared minus 2x on the interval 1 to 4. Okay, so we now have a formula for the average value. The average value is given by this formula right here. So let's use it. Okay, so the average value remember, that is 1 over b minus a is equal to the integral from a to b of f of x dx. Not equals, times b minus a times is equal to f of c. There we go. Alright, so what is my a, what is my b? B is 4, a is 1, and f of x is 3x squared minus 2x. So we have that f of c is equal to 1 over 4 minus 1 times the integral from 1 to 4 of 3x squared minus 2x dx. Well, last time I checked, 4 minus 1 is 3, so this is 1/3 times the integral from 1 to 4 of 3x squared minus 2x dx. If you take the antiderivative, if you find the antiderivative of 3x squared, you get the following. You get 3x cubed over 3 minus 2x squared over 2. And this we're going to evaluate from 1 to 4. Notice that there's some cancellation here because the 2 and the 3 will cancel out. So we have x cubed after you cancel out these 3's minus x squared after you cancel out the 2's. Again, we're evaluating this from 1 to 4. So let's evaluate that. We have 1/3 times, and again, I'm going to do f of b first and then minus f of a. So we have, by the fundamental theorem, f cubed minus 4 squared. So this is my f of b minus, I have 1 cubed minus 1 squared, and this is my f of a. So what do we have here? We still have the 1/3 on the outside times 4 cubed. Well, 4 times 4 is 16. 16 times 4 is 64. Minus 4 squared, which is 16. Right? Minus 1 minus 1, well, that's just 0. So minus 0. Because 1 cubed is 1, 1 squared is 1, 1 minus 1 is 0, so minus 0. So now I have 1/3 times 64 minus 16, that's going to be equal to, let's see, I'm getting old, 48, so it's going to be 48 over 3. 48 over 3 is divisible by 3 because 4 plus 8 is 12, so this is equal to 16. Yeah, 16. 3 times 6 is 18. 3 times 1 is 3, and 1 is 4. So 48. There we go. So we have the average value on the interval 1 to 4 is 16. So the average value of f of x on the interval 1 to 4 is 16. So that is how you find the average value of a function. You could use this average value problem, this theorem, to find a lot of different things in application, such like speed, speed of a bullet, speed of a vehicle traveling, on all of these things. So this is a pretty neat little section right here for the mean value theorem. Right? So that is all she wrote for this piece of information. I hope you learned something, and on to the next part of this lecture.